Hello everyone, my name is B. Sadvik. I am from CSS D section. My topic for operating systems concept video is what is threads. What is a thread? A thread is a flow of execution through the process code with its own program counter, system registers, and stack. A thread is also a lightweight process. Thread provides a way to improve application performance through parallelism. Each thread belongs to exactly one process and no thread can exit outside a process. Single and multi-threaded process. In single-threaded process, it consists of code, data, and files, one register, one stack, and one thread. Whereas in multi-threaded process, it consists of code, data, and files along with multiple registers and multiple stacks and multiple threads. Process is a heavyweight or resource intensive. Thread is lightweight, taking lesser resources than a process. Process switching needs interaction with operating system. Thread switching does not need to interact with operating system. In multiple processing environments, each process executes the same code but has its own memory and file resources. All threads can share same set of open files, child processes. If one process is blocked, then no other process can execute until the first process is unblocked. While one thread is blocked and waiting, second thread in the same task can run. Multiple processes without using threads use more resources. Multiple threaded processes use fewer resources. In multiple processes, each process operates independently of others. One thread can read, write, or change another thread's data. Advantages of threads. Threads minimize context switching time. Use of threads provides concurrency within a process, efficient communication, economy. It is more economical to create and context switch threads, utilization of multiprocessor architectures to greater scale and efficiency. Disadvantages of threads. Blocking of parents thread will stop all child threads. Lack of security. Types of threads. Threads are implemented in following two ways: user level threads and kernel level threads. User level threads. User level thread implement in user level libraries, so thread switching does not need to call operating system and to cause interrupt to the kernel. In fact, the kernel knows nothing about user level threads and manages them as if they were single threaded processes. Advantages of user level threads. User level threads does not require modification to operating system. Easy to represent and manage. User level thread can run on any operating system. User level threads are fast and efficient. There is lack of coordination with disadvantages of user level threads. There is lack of coordination between threads and operating system kernel. User level threads require non-blocking system, i.e. multi-threading kernel. Kernel level threads. In this method, the kernel knows about and manages the threads. No runtime system is needed in this case. Operating system kernel provides system call to create and manage threads. Advantages of kernel level threads. Kernel can simultaneously schedule multiple threads from the same process on multiple processes. If one thread is in a process is blocked, the kernel can schedule another thread of the same process. Kernel routines themselves can multi-threaded. Disadvantages of kernel level thread. Kernel level thread are generally slower to create and manage than user threads. Kernel requires thread control block TCB for each thread in pool, hence complexity increases. Difference between user level and kernel level threads. User level threads are faster to create and manage. Kernel level threads are slower to create and manage. Implementation is by a thread library at the user level. In kernel level threads, operating system supports creation of kernel level threads. User level threads is generic and can run on any operating system. Kernel level thread is specific to operating system. Multi-threaded cannot take advantages of multiprocessing. Kernel routines themselves can be multi-threaded. Multi-threading models. Some operating systems provides a combined user level thread and kernel level thread facilities. Solaris is a good example of combined approach. Multi-threading models are three types: many to one model, one to one model, many to many model. Many to one model. Implementation of many to one model. Many user level thread to one kernel level thread. Allow the application to create any number of threads that can execute concurrently. In this implementation, all threads activity is restricted to user space. Additionally, only one thread can access the kernel at a time, so only one schedulable entity is known to the operating system. Example of the kernel level thread. Many to one model. kernel level thread to the user thread. One-to-one model. The one-to-one model, one user level thread to one kernel level thread, is among the earliest implementation of true multi-threading. In this implementation, each user level thread where the application is known to the kernel and all threads can access the kernel at the same time. The example of the one-to-one model, kernel level thread to the user thread. Many to many model. The many to many model, many user level thread to many kernel level thread, avoids many of the limitations of the non one-to-one model while extending multi-threading capabilities even further. The many to many model, also called two-level model, minimize programming effort while reducing the cost and weight of each thread. Here is the example of many to many model, many kernel threads to many user threads. Here it comes to the end of the concept video. This is all about threads and different types of threads and the differences between different types of threads and different model of multi-threading and multi-threads. Thank you.